I want to teach you how to draw organic structure step by step. And we are going to use the skeletal formula, the fully display formula, and the condensed formula. How do you use these various methods in drawing organic or structure? It's very important to know this here. Not only that, I also teach you how to identify the numbers of functional group, the numbers of what? How to identify the functional group in the organic compound. Then I will teach you how to calculate the numbers of pi bond and sigma bond. So make sure you stick to the end of this video. Now we are going to start off with what? With the skeletal formula. Then we transfer the skeletal formula to what? To the fully display formula, to what? To a condensed formula. So you know to was stick to the end of this video here. So we are going to start with this structure here. Now this is called skeletal structure. It's called skeletal structure. Now in skeletal structure, you don't actually show the numbers of carbon atoms and the hydrogen. You only indicate what the functional group present. You get. And when you go to skeletal structure, each of these points here, or each of those vectors indicate numbers of carbon atoms. Do you get that? So I have 1, 2, 3, 4, 5, 6, 7, 8. Right? There is no carbon here because this one here is carrying what? OH. Do you get that? So now let's transform this skeletal structure now to a fully displayed formula. So here we have skeletal form. Let's convert it to a fully what display formula here. So the first one to do here is what? Know the numbers of points, which is 1, 2, 3, 4, 5, 6, 7, 8. 8. So what will be 8 carbon 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Do you understand? So let's confirm it again. 1, 2, 3, 4, 5, 6, 7, 8. Do you understand? Now, if you check this one here, it's only at that point. Now, what you want to understand here is that carbon must have 4 bonds. No matter what you do, carbon must have what? 4 bonds. So in the sense that this carbon here is only having 1 bond because it's bonded to what the next carbon here, right? So it means that this carbon here is going to have 3 hydrogen to make it what 4. So it's going to be 1, 2, and what? And 3. This is that 1, 2, 3, and 3. So this one is what is satisfied here. Now let's go to this other one here. The second point. Now here this carbon here must have 2 hydrogen, right? So here we have 1 and 2, right? Now let's go to what the next one, number 3. Now this number 3 here is having a double bond. Can you see that? So between number 3, 1, 2, 3, 4. Between number 3 and number 4, there's a what? Double bond. So 1, 2, 3. Between number 3 and number 4, there's a what? There's a double bond. This is that. Now because there's a double bond here, what you need to do here? There is how many bonds is this carbon having now? It's going to be what? 3 bonds, right? Then you need what? 1 hydrogen. So you can put what? 1 hydrogen at this point here, right? Now it can either be up or it can be down. Now the next one here, the same thing, you go to have what? 1 hydrogen, right? So we now move over to this one here. This one we have what? 2. This one we have what? 2. This one we have what? 2 hydrogen, right? Do you understand? Now, this one you're seeing here is a carbonyl functional group. That is, this carbon here is having what? A double bond oxygen, right? They bond to what? OH. Can you see that? So this is what the skeletal structure. This is what fully display formula here. Do you understand? So you can start here. This is called the fully display formula here. In this fully display formula, the way the atoms are being bonded are being shown drawing full, right? And the numbers of hydrogen are being shown. Then the functional group are being shown how they are being what connected. Do you understand? So that is different between what fully display formula and skeletal what formula. Now let's compare this one to what? To a condensed formula, because most times you see condensed formula in the exam. If you want the name organic structure, they normally give you what in a condensed formula. Now in a condensed formula, you group the atom, you don't separate them. Like for this one here, if you look at this one here, this carbon atom is having what? 3 what? Hydrogen. So you group them to be what? CH3. Can you see that? Now, and you don't use dash. Do you understand? You don't want to use dash. Then next one is what? CH2. So you have CH2, right? Now here we have third one is what? Is CH. Then you have the other one CH. Then here we have CH2. CO2. Here we have CH2, right? Here we have CH2, and here we have CO2H. Can you see that? 1, 2, 3, 4, 5, 6, 7, 8. This is that. Now from here, you may not actually want to know the type of bond present until you draw it to this fully displayed formula here. So this is called skeletal formula, fully displayed what condensed formula. It's very, very important to know how to draw this here. You get. Now, what are the functional group? Because you be given the instruction, they ask you what is the functional or what are the functional group present here. Now, I have done a complete video when I explain the various functional groups that I call introduction to organic compounds. So where I explain the full details. If you have not checked out that video, I will leave the link and the description below. It's very, very important to check out that video. Now, let's look at what the functional group here. If you check it very well, this one have a double bond here. And double bond, so the functional group present, functional group, here we have what? The alkene. Here we have what? Alkene. Then here we have the carboxylic acid. You get this called carboxylic acid. So you can say carboxylic what? Acid. It's very important. Now this carboxylic acid, you also know what? Alkanoic acid. Alkanoic acid. It's very important here. You get. So you must know how to identify what the functional group is. Very important. Like next thing you want to do here, numbers of pi bond and what sigma bonds. How many pi bonds do we have here and how many sigma bonds do we have here? As a chemistry student, it's very, very important to know how to count the numbers of pi bond and what and sigma bond. So what I want to do here, I'll be wiping this place out. And here. So let's look at it very well. Now, if you cross check it very well, now let's get numbers of what? Numbers of pi bond. How many pi bonds do we have? Now, in order to do that here, you need to understand this here. Now, let me just throw back your mind. Let me just explain something to you with the hybridization. Remember, we have called the sp3, sp2, and what? And sp, right? Now, sp3 means what? A single bond. A single bond. Now, when I see an sp3 hybrid orbital or carbon, is what? That is, it only contains a single bond. And a single bond is called sigma bond. So here we have one sigma bond. It's okay. One sigma bond. Now, sp2 is what? Is the double bond. It's a what? It's a double bond. But it has what? One sigma bond and one pi bond. Here we have one sigma bond, one pi bond. Right? Now for this one here, sp, you have triple bond. Right? So it's going to be one sigma bond and what? Two pi bond. It's very important. One sigma bond, one pi. Okay, two pi bond, two pi bonds. So instead that, it's very important to know all these things here because you see them in the exam. Because some people now, if this kind of stuff in the exam, they will not be able to what do it correctly, and they which will make them to what fail that particular what question. So that is the reason why I'm taking this video to what to explain this set, this thing for you. So now let's look at what mass of sigma bond and mass of what pi bond. So I believe you have taken it out, right? Copy sign a note. So here we have a double bond here. So here we have two double bonds. We have one here we have one here, right? So there's a double bond here, there's a double bond here. Now this will contain one pi bond. One what? Pi bond. This will contain one pi bond, right? So how many pi bonds do we have here? Because here we have double bond, two of them. There is a double bond contain what? One pi bond, a double bond contain what? One pi bond. So you mean that here we have two pi bonds in the what? In the structure. Two pi bonds in the what? In the structure. So now let's look at what numbers of what sigma bonds. Numbers of what sigma bonds. numbers of sigma bonds. So how do we calculate numbers of sigma bonds? It's okay. Now, each of the single bond are called sigma bond. Each of the single bond are called sigma bond, and a double bond contain one sigma bond and what one pi bond. So let's start from here. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22. Now, some will stop at 22. Now, do you know that there's also a sigma bond here? So we should make it what? 23. So here we have 23 sigma what? Bond. Okay, 23 what? Sigma bond. Now, so many students will fail this stuff in the exam. I'm telling you the truth. Because people they don't know how to calculate numbers of pi bond and what numbers of what sigma bond. That is why it's very, very important to know how to draw organic structure. We represent it in skeletal structure, we represent it in fully display or in the condensed structure. Do you understand? So now let's enter on that one here. Let's look at this structure. Now, if you look at this structure is a little bit complex. So when you convert this structure to a condensed formula, so when you convert this structure to what? To a fully display formula, then to a condensed formula, then we need to get what numbers of what? Pi bond and sigma bond. Do you understand? And the what functional group that are what present. So how do we do that here? So remember that each of the points represents mass of carbon atom, right? So if you look at it here very well, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see that? Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see that? So now let's start with that. So we can label it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see that? So each of the points here, they are all carbon atom. Can you see that? Now at this point here, we have a carbon atom that carry what? Three what? Hydrogen. So you're going to be 1, 2, and what? And 3. Can you see that? Now this point here, you're going to carry 2 hydrogen. So it's going to be 1, 2, right? Now you see this carbon 3 here. Carbon 3 is having a carbon, and now because if you share very well this carbon 3 is attached to 1 point and what 2 points. This point means what? A carbon atom, and this point means what? A carbon atom, and another what? Carbon atom. Now this one I'm seeing here is also the same thing with this guy. Can you see that? So you can also place it up. It's not necessary that it should be down. So I can what? Place this guy up. I can do it like this: a carbon and a 2 carbon atom here. So this guy I'm seeing here means what? This guy. This one that connected to here means what? These 2 points. Can you see that? Yes. So now remember, this one must have hydrogen, right? So we have 1, 2, and 3, right? Now because carbon must have the octet. Now what about this one here? This one must have 2 because this carbon atom here is already having 2 bonds, right? This one here is having this guy is connected to what? To the parent chain. So we have hydrogen and what? And hydrogen. Can you see that? And what? Hydrogen. Right? Now, let me go over to what? To the number 4. You can see that number 4 have a triple bond. Between these 2 here, there's a triple bond. So you know put that triple bond here. Can you see that? There's a triple bond between 4 and 5. So there must be a triple bond here, right? Now, remember, carbon must have 4 bonds. This one is already having 4 bonds. So there's no point of putting hydrogen again. So no hydrogen is needed here again between these 2 points here. Now let's move towards 6, which is one here. You're going to have 2 hydrogen, right? Now to obtain the octet. Then you have number 7, here we have hydrogen, right? Now at number 8, I have a double bond here. Can you see that? I have what? A double bond at this point. Then at number 9, I have what? This guy, right? This one here means what? 2 carbon atom, 1 and 2. Now remember, this guy must have the octet, so we're going to have 2 hydrogen. Can you see that? Then so you're going to have what? 3 hydrogen. Right? Now, remember, this one here is this guy here. Is what having this one here. That is, you need what? 1 hydrogen at this point. Right? You need what? 1 hydrogen at this point. Now, this one here is having what? Like this carbon here, the last carbon here I see here, is having what? A double bond oxygen. And then attached to what? Hydrogen. Can you see that? So, this one here is this guy. Can you see that? So this is called the skeletal formula. This is called fully displayed formula. Do you understand? Now, before we start converting into what to the condensed structure, which I'm going to teach you in a few minutes. Now, let's calculate numbers of sigma bonds, because through this place here, you can calculate what numbers of sigma bond and what numbers of pi bond. You get? So, how many sigma bonds do we have and how many pi bonds do we have? Now, let me say this here. From here, you can easily get your pi bonds, right? But you cannot easily get from here. So you need to convert this guy to this other one here. Does that make sense here? So now let's calculate numbers of pi bonds. Here I have what? A triple bond, right? And a triple bond contains 2 pi bonds, right? Contains 2 pi bonds. So here we have 2 pi bonds. So it's going to be 2 plus. Now, here I have a double bond. A double bond contains 1 pi bond. So it's going to be 2 plus 1 plus. Here we have a double bond here. You have what? 1 pi bond plus 1. So how many pi bonds do I have here? 2 plus 1 plus 1 is what? Is 4. So you have 4 pi bonds. 4 what? Pi bonds. So now look at what the numbers of sigma bond. Although it's going to take us time, but let's take step by step. How do you calculate numbers of sigma bonds? So we're going to start from here. Right? So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? Then 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Here we have 40 sigma bonds. So you know what? Take it step by step. So here we have 40 sigma what bonds. 40 sigma bonds. Do you understand now? So the question will be, Chemchris, how do we convert it to what? To a condensed formula? Because this skeletal formula, this one is a condensed formula. How do we convert it to what? To a condensed formula? But before we do that here, what are the functional group? What are the functional group? Yeah, the functional group here, functional what groups that are here. Here we have alkyne. So the first one is what? Is an alkyne. Because of what? A triple bond here, right? Now, here is a ketone. This one here is a ketone functional group. Because ketone and iodine have the same carbonyl functional group, right? But this carbon here, this carbonyl functional group, is in between 2 carbon atoms here. So it's called a ketone functional group. Ketone functional group. Why this one is what? Is an aldehyde functional group. So here we have an aldehyde. An aldehyde functional group. You just can. So these are you what? Identify the what? Functional group. Now the next thing we want to do here, so we'll convert to a condensed formula. How do you convert to a condensed formula? It's very easy. It's what? It's very easy. Yeah, remember in the condensed formula, you group them, right? So here we're going to be CH3, right? We're going to be CH3. Then you have, now let us put dash here because I really want to make more sense here. So here we have CH2, right? Now, this one you are seeing here, this carbon here, is having what? CH3 and CH2. So it's going to be, look at it here, going to be CH3. Now this CH3 is this guy. Can you see that? Now I also have what CH2, CH2. So here we have CH2, CH2. Can you see that? So now guys, I'm drawing to that one here, right? So this one carry this guy and this guy. Now here we have between these 2 points here, there is no hydrogen, so it's going to be C, C, right? C and C. So that this carbon do not have anything here. This one do not have anything here. That is meaning. Then here we have what? CH2, CH2. Here we have CH2. Please, I'm going to wipe this place here. Yeah, I'm wiping it. Please, I'm wiping it. So let me wipe it out. So here we have CH2, CH2. Now here we have CO. So here we have CO, right? Now this one here is carrying what H and what C, CH2, CH3. So going to be C. Here we have hydrogen, right? This one here have hydrogen and what CH2 and what CH3. Can you see that? Now then this one is what COH. That is it. So this is called the condensed formula. So can we ignore the dash? So if you ignore this dash here, here we have CH3, CH2. That is it. So this is what is the condensed formula. This is what fully displayed formula. You can see it's very, very important to know how to do this here, because at times you'll be giving in a skeletal structure. Now at times you'll be giving a condensed structure and say give the I part to nomenclature. Do you get us? So before you can start naming the nomenclature of the organic compound, it's very important to know how to draw structures. Do you understand? So we'll do one more before we end this class. Okay, let's look at this compound here. Now this is called a condensed compound here. Therefore, let's come back to a fully displayed formula. Then let's convert that fully displayed formula to a skeletal formula. Do you understand? So let's look at this other one here. So this one means what? A carbon with what? 3 hydrogen. So here we have a carbon, here we have hydrogen, hydrogen, what? And hydrogen, right? Then here we have this one here, hydrogen, what? And CH3, right? So this hydrogen atom, we have hydrogen, what? And CH3. Then here we have, now here we have a triple bond, right? Now because this carbon here and these two here, they are not having a double bond, right? So this one connected to each other with a triple bond. Now, whenever I see anything like CO means what? A carbon atom connected to what? To what? A double. A carbon atom connected to what? To what? Double bonds. Can you see that? So now here we have CH2. Please understand that this one CH2 here is not the same thing as CH3. It's what? CH2 3 times. So we're going to be C hydrogen, hydrogen, C hydrogen, hydrogen. This one means C hydrogen and hydrogen, right? Now we look at it very well. Now this one means what? 2 CH3 attached to it. So we're going to be C hydrogen, hydrogen and hydrogen. So but we can just group it now. Let us group it there to avoid too many bonds. So we're going to be CH3 and what? CH3, right? Then this one is what? Is a carbonic acid functional group. It's okay. So this is called the condensed formula. This is called fully what? Displayed formula. So I want you guys to do something for me. How many pi bonds do we have here? How many sigma bonds do we have here? So you leave it at the comment section. So now, what are the numbers of pi bonds? What are the numbers of sigma bonds, right? And what are the functional groups that are present here? What are the functional groups? So that would be your own assignment. I want you to try for me here. Leave the answer at the comment section.